All right, good evening, everyone. I hope you all had a great day. For most of you, this was your first day of school, right? The first day with the students back. I hope everything went well. I hope you have a great timetable, that you have a great head of department, that you have great students, fun colleagues. Well, basically, I hope that this year you have the best possible work environment for you to grow up as a professional, but also to be happy to go to work every day, or at least not being depressed about going to work every day. All right, so I'm very happy to meet you again tonight. We have a lot on our plate tonight. There is a lot of content that we need to go through, and a lot of document that will support this workshop tonight. But before we move forward, can I just make sure that everybody hears me well and you should also see me tonight? Is everything working fine for everyone? Yes, all good. Okay. So not many of you tonight. The workshop is fully booked, but I guess most of your colleagues would rather simply watch the video recording. I was told that some teachers struggle to watch the video recording. Is this the case for you guys? Have you tried to watch the video recording online? If you've experienced any difficulty to load the video on the website, just send me a message in the chat box. So then I can try to fix it. I don't know if everybody struggles or not. Sometimes the website is a bit slow. Maybe you've noticed. There is not much I can do about it. The website or the company who's hosting the website is conducting some kind of maintenance and has started the maintenance process last week. So this was the last week of August, and it's not over yet. They are still making copies of all documents, databases, and all. And this has the effect of slowing down the website. So this is both for Econ Mentor, Econ Doctor, Econ Joker. All websites are hosted by the same company. And this week was a bit complicated, was a bit slow. So I hope that everything will be better soon. Just a quick reminder again, I still receive some registrations from teachers who either forget to send their code, like the one that starts by EM, or who forget to click on confirm at the bottom of the page. So please, please, please make my life easier. Make sure that you complete both those steps when signing up for an upcoming event. Okay, I think we are ready to start. So there are actually two things. This is the same theory. We will talk about consumer theory today, but I've actually divided. Let me just share my screen. That's going to be easier for you. Just a sec. There are still people trying to enter the waiting room that show up a bit late. All right, I'll share my screen. It's going to be easier. Just to explain to you, you should now see my screen. Yes. So yeah, I've actually divided consumer theory into two parts. Well, I could have merged it, but I like to separate it because essentially the first part really is about understanding how consumers make decisions. consumption decisions. So this is really about, right, we have a budget constraint, we have preferences, how do we maximize our utility, boom. So this is really what this is about. And then the second part is essentially how consumers respond to changes. So it could be a change in income, could be a change in price, and we analyze, of course, and we distinguish between the income effect and the substitution effect. So I like to separate these two parts because to me this is a bit different, even if, of course, this belongs to the same consumer theory. As always, you have plenty of documents that you can download from the resource section. You have the summary, only 5 pages for the first part. You have the list of definitions and the concept cards, and you also have all the essay questions that are about consumer theory. I honestly don't really like the way Cambridge organizes this chapter, because if you look at the syllabus, it seems like Cambridge distinguishes the law of diminishing marginal utility, or basically what they sometimes call marginal utility theory, and sometimes what they call indifference curve theory. And honestly, that's a bit confusing because I've never heard of that before. I have taught microeconomics for a long time, and I've never really, there is no difference, right? This is just the same theory. So it's always a bit confusing when they say using marginal utility theory or using indifference curve theory, because I will show you today that this is just one theory, and they just belong together, and there is no separation. There is no difference between marginal utility theory and indifference curve theory. So of course you can use diagrams to explain, and I guess this is what they mean by indifference curve theory. Or you could use something like the equimarginal principle. Maybe this is what they call marginal utility theory. But again, in reality, they both belong to the same theory, and it will become very clear as we go through the content. Okay, let's go. Let's have a look at this PPT. Okay, so there are essentially 3 stages. When you teach this to your students, there are 3 chapters or 3 parts for them to understand how consumers make decisions. First, what they can do, which is about how much income they have and about the price of the goods and services that they can buy. Okay, this is not about what they want, this is not about what they like, it's just, all right, what can I afford among all the possible baskets or combinations of goods and services. Then once we can distinguish between what the consumers can buy and cannot buy, then we introduce the concept of preferences, what the consumer really wants, really likes. And in economics, we don't really call that satisfaction, we call that utility. So that's where we talk about utility, the difference between total utility and marginal utility. That's when we will introduce indifference curves, and we will also briefly talk about the marginal rate of substitution. And then we bring this together because we know what the consumer can afford, so what we can buy and what we can't. We know what the consumer wants because we have information about the consumer preferences. So then once we bring these 2 elements together, then we can understand how the consumer is effectively going to make a decision to choose the combination of, here we simplify and we only consider 2 goods. If you look at more advanced microeconomic books, they will consider many more goods at the same time, but it's essentially the same idea. Our job is simply to find the best combination of good X and Y, the quantity of X, the quantity of Y, that will maximize the consumer's total utility for a given budget constraint. Okay, so that's what we do. First, what the consumer can buy. Second, what the consumer wants to buy. And then we bring this together to solve the problem of the consumer. All right, let's go. So the first part really is about the consumer, the budget constraint. And of course, you know that it is represented by the budget line. So let's start by introducing some letters, and these are the most typical ways you can refer to income. W usually stands for wage, so that's why we use W. We don't really use Y. Y is usually a letter that we use in macroeconomics, because Y is real GDP, and real GDP is the same as a national income. So that's why usually Y stands for income in macroeconomics. In microeconomics is most of the time we use the letter W. PX, price of good X, PY, price of good Y, XY, these are quantities, and the vector XY is a bundle, a combination of good X and good Y. Hold on just a sec. We get more people in the waiting room. Okay, so now we have that. So the budget constraint is very simple. Essentially, this is what I spend on good X and good Y. Okay, XPX is what I spend on good X. YPY is what I spend on good Y. And the budget constraint simply tells me you can't spend more than what you have. So your income, W, must be greater or than or equal to how much you have spent. That's it. That's what we call the budget constraint. But of course, you see that this can be greater, strictly greater, or equal. Strictly greater would mean that you do not spend all of your income. And in that case, we would be below the budget line, you know that. And the equality would indicate that, well, we spend everything we have. We do not have any income left. The income that we have left, we sometimes call that the residual income, okay? A residue is something left. Okay, and then once we have understood what the budget constraint is for the consumer, we can actually define the budget line. So the budget line is just a combination, all the combination of good X and good Y. So sometimes we call that combination, sometimes we call that baskets, sometimes we call that bundles. So you can choose whatever word that you want with your students, but try to remain consistent, okay? Because if you change from one word to the other, it's going to confuse them. So usually I like combinations. So I will try to stick to the keyword combination. So yeah, so that's essentially all the possible combinations of X or of Y that are such that the consumer spends all of his or her income. So this way, the income, W, is exactly equal to the expenditure. And actually, what I like to do, once we have it this way, it's to, well, if you want to solve this equation for Y, sorry, so you can express Y as a function of X, and the other parameters of the model. Why is this useful? Because for those students who are well, confident at math, immediately they will see that, hey, this is the equation of a straight line, yeah, where W over PY is the vertical intercept, okay, minus PX over PY, it's the slope of your straight line, and X, well, that's your variable. So that's quite handy if they want to draw it, okay, because they will they just have to remember this. So then it's going to be super easy to know what's going to happen to the budget line if you have a change in income, or if you have a change in the price of X, a change in the price of Y. You simply to have a look at this equation, and then graphically speaking, it's going to be very simple to find out in what direction your budget line is going to shift. So it's very important that they know that, like, the general form or the general expression of the budget line. All right, and of course, it pretty much looks like a PPC, right? Everything that is on the PPC, we have used all the resources. So here, resources would be money, would be the income of the consumer. Everything below the PPC was such that we had resources left. We had not fully used the resources. Here, it's the same idea. We have not used all of the income, but it's attainable. Yes, the consumer can afford any combination of X and Y that lies below the budget line. And any combination that is above the budget line is such that the consumer does not have enough purchasing power. Rather than income, you should say purchasing power, because of course, The budget line is, well, depends on how much income we have, but it also depends on the price of good X and good Y. Okay, so the consumer's real income essentially means purchasing power, what I can buy with my nominal income. A2 students have taken AS, they know what is the difference between real and nominal, so you can explain to them that yes, the real income is essentially, to simplify, the purchasing power of your nominal or money income. All right, good. So usually what I do then is to I graph it. So, okay, we see the vertical intercept is indeed W over PY. Okay, we have it here. The slope is indeed PX over PY, the price ratio, and that's going to be very important later. So emphasize that to your students. Remember, the slope of the budget line is the price ratio. And of course, you can calculate that you can show that the horizontal intercept is W over PX, which makes sense, right? If you use all of your income to buy only good X, you can buy W over PX. And same thing, if you use all of your income just to buy good Y, then you can buy W over PY. All right. Then what you can do, just take 3 points, one below, one on, and one above, and ask your students, all right, so what can we say about each of these points? And they should tell you, point A, yes, I can afford it, but I have some income left. Point B, they should tell you, yes, I can afford it and I have used all of my income because it is on the budget line. And then point C, I can't afford it. My purchasing power, my real income is not sufficient for me to be able to purchase this combination. Okay, good. Then you can ask them, all right, and which one is best? So of course you would be tempted to say C, because it seems like we have more of both goods, but you should emphasize that for now we don't really know what the consumer wants. Okay, if I'm allergic to good X and good Y, or if I really eat too much or drink too much, then combination C might not actually be the best. We don't know anything about what the consumer wants so far. It's just what we can buy and what we can't. Right, then there is this whole section about the different shifts of the budget line, but there is not much to say because again, if the student knows that, this equation, and everything is just straightforward, right? We see that if we change the income, if we increase income, the vertical intercept is going to increase and the slope is not going to change. If we increase the price of good X, for example, we see that the vertical intercept is not going to change. However, the budget line is going to become steeper. So simply looking at this equation, your students, they can find out what's going to happen to the budget line in any circumstance. I'm pretty sure G12 students are good enough at math to be able to figure this out. And if not, well, they should be worried. All right, so I've simply, this is a summary. I'm not going to go through this summary, but yes, that's essentially all the possible changes. So first, what if the income changes? So we have a parallel shift. However, if you have a change in the price of one good, then the budget line is going to pivot along the axis on which the good whose price changes is labeled. That was a complicated sentence, but yeah, so if you change the price of good X, the budget line is going to shift along the X-axis. If you change the price of good Y, then the budget line is going to shift or to pivot along the vertical axis. All right, then what I did is that I graphed all possible cases. So the increase in income, decrease in income, increase in the price of good X, decrease in the price of good X, increase in the price of good Y, decrease in the price of good Y. So 6 possible cases. Usually there is no problem. Students, they get that pretty easily. And to conclude this section on the budget line, because we are done pretty much, I've designed this simple exercise where we have one consumer, Sabrina, and she has given income, W. There are only 2 goods, pan flutes and kites. I give the price of flutes, the price of kites, and then there are just a few questions about what she can do, what she can't, what combinations of pan flutes and kites she can purchase, which ones she cannot. Then I asked to draw the budget line. And then there are 3 things that change. First, there is a change in income. Then there is a change in the price of pan flutes. And finally, there is a change in the price of kites. And then your students are expected to graph what's going to happen to show the shift of Sabrina's budget line in all of these 3 situations. So if you look at the student version of the PPT, just to show you how it looks like, so you can print it right away. Let me share it so you can actually see it. So this is how it looks like. All right, so you have the exercise, you have like one first just set of axes, and yes, look, the kite is moving. How advanced. Then one for the first shift of the budget line, another for the second shift, and the last set of axes for the last shift. So your students simply have to use those empty diagrams to solve the exercise. All right. And if you look at the the teacher's version, then you have the answers. All right. You have the answers. So just walk your students through this exercise. It is very simple, so I don't think we should spend too much time on this together. It is very straightforward. If you have any doubt, if you don't really know how to explain it, send me a message, but I really think that that's the easy part. So we should move on, right? And you have the key anyway. You have the key for this exercise. All right, and we are already done with everything about the budget line. Do you have any questions? If you do have a question, type it or talk to me. If you don't have a question, please just type go or something like that so we can move on. Are we ready to move on? Should I take this as a yes? Okay, thank you. Xiaolu. Does it mean my Chinese is really bad? Does it mean small? I know Xiaolu means small path, right? Or small road, but that's probably completely not that. But when I was hiking in the mountains, I remember that Xiaolu meant like a small path, not the main road. All right, let's talk now about let's just close the student version. Let's get back to the teacher's version. There is one question in the chat box. I'm interested in whether students ask you questions concerning the comparisons between PPC and the budget line. Well, usually I just tell them that it works pretty much the same, it's the same intuition. If you consider that here we are not talking about productive resources, we are talking about income. All right, but apart from that, if you really explain to them that's usually basically the only difference, then yes, a budget line works at least in its definition and its representation, not in the way it shifts, of course, but in how you can interpret something below the budget line, above the budget line, and on the budget line. It's pretty similar. And of course, moving along the budget line has an opportunity cost, because you would consume more of one good, and therefore you would have to give up another product. So I usually anticipate their questions, and I just point at the fact that, hey, look, that actually works pretty much the same way. And that makes it easy for them. Okay, let's talk about preferences now. So when I mean preferences, yeah, I mean what people want, or need or want, what they want to purchase. So obviously we don't unfortunately we don't really use just satisfaction. That's maybe too simple for economists. They like fancy words, so instead they use utility. But yes, just tell your students utility, that's just satisfaction. And so yeah, it's a level of satisfaction, and the unit is called a util. All right, so that's the unit of satisfaction, a util. And there is very important difference that the students must know, and they must be able to define these two keywords very precisely, the difference between total utility and marginal utility. Well, total means total. So you have a combination, a certain quantity of good X and a certain quantity of good Y. You consume all of it. And then as a result, overall, you have a certain level of satisfaction that comes from the consumption of your entire basket. Okay, and we call that the total utility, simple. And marginal utility, your students are already familiar with this concept of marginal. We've talked about marginal cost, marginal benefit, so they should understand what it's like. So the marginal utility, we only look at the change in total satisfaction, the change in total utility that is generated by the consumption of the last unit. Sometimes we say the additional unit, sometimes we say the last unit. I find it easier when there are especially some exercises with numbers to use the definition, the last unit, that avoids some problems when we have tables. That's, to me, that's just better. So of course, when we talk about the marginal utility, we focus on just one good, okay? Unlike total utility that, takes into account all possible goods, but marginal utility, we just look at one good. And we look at by how much total utility has changed, usually increased, once we have consumed, or after we have consumed the last unit. All right, that's a very important difference. Then you have an example here to really emphasize what the difference is between marginal and total utility. You have this first example there. You also have a table just after. You can actually, I don't know if in the student version, I don't know if it's already filled or not, but it could be interesting to delete this last column for your students to be able to fill this last column. So we have the quantity of one good, okay, that's just a one good example. The total utility that is generated by the consumption of this good. So we see that at first it increases and then it eventually starts to decrease, okay, after 5 units, but doesn't really matter for now. And what we can do is just to look at, all right, the change in total utility that is generated by the consumption of the last unit. So of course we can only start from 1, okay, we don't start from 0, we can only start from the first unit. So first unit from 0 to 40, that's 40. Second unit from 40 to 65, that's 25, blah, 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 okay? So using this method, we can actually fill this second column or third column to display the marginal utility. Well, we see that it decreases. Just tell your students, we'll talk about that later, about a certain law of diminishing marginal utility. And in this particular example, it becomes a negative at some point. You might ask your students, why is this possible? You consume more and your satisfaction decreases. Okay, just to get them to think about that. But this is a possibility that we will not consider this year. Otherwise, it would be too complicated to find the equilibrium of the consumer. I will explain to you why we cannot have this type of situation in this course. So we have this schedule, and then we can actually represent that on a diagram, okay, just using this number. So the first diagram shows the total utility, okay, so 1, 2, 3, 1 to 6 units of one good. So I see that the total utility increases, but you should note that it increases here at a decreasing rate. Again, that's going to be related to the law of diminishing MU. Yeah, MU is just quicker than marginal utility. Yeah, and then it starts to decrease. We will see that we call that non-monotonic preferences, but this is an assumption that we will reject at the beginning, or we will assume the opposite. We will assume monotonic preferences. Otherwise, we'll have big problems. I will explain in a minute. So yeah, I can use this table to show the total utility. And then I can use the last column to show the marginal utility. I see that it decreases and it even becomes negative after 5 units, which means that if I consume the 6th unit, my overall satisfaction is actually going to decrease. So here I only look at one good, okay, to simplify. But in practice, what we will do, we will mostly look at 2 goods, good X and good Y. All right, and this takes us to the law of diminishing MU, well, which is extremely simple to understand because we've all experienced it. It's the idea that the more you consume of the same product, the lower or the smaller the additional satisfaction that you receive from each successive unit. All right, that's it. And the typical example, I apologize, it's not a very original example, but it doesn't matter in this case because it is the one that is the easiest for students to understand, is about either food, something when we eat or when we drink. So in the example that I give is someone who's lost in the desert and has not had anything to drink for a long time, that is almost dying, and finally this person finds an oasis, like this a place with, let's say, a lake of drinkable water and some palm trees. And all right, so basically his life is saved, and of course the first drink is going to save his life, so a very high marginal utility. Second drink will still have a very high mu because he's still very, or she's still very thirsty, and then the more this person drinks, the less thirsty he or she becomes, and therefore each additional drink generates a lower and lower, smaller and smaller extra satisfaction. And we could even reach a point, and actually in practice we do. Okay, if I take a big glass of water and I drink it very, very well, but if I take 10 of these, there will be a point where my marginal utility will actually be 0, which means that the last glass has neither increased nor decreased my overall satisfaction. But it's very likely that if I decided to drink an additional glass of water, then my overall satisfaction might actually decrease, which would indicate a negative marginal utility. Well, simply because here there is something that is scarce, which is the space in my stomach, right? I can only fit a certain amount of water. All right, well, easy. You can ask your students to find other examples with food or with anything else. You can try to get them to find examples of products for which this law does not apply. So finding examples of products for which the marginal utility is actually increasing, but I've never myself found any convincing example. I know that in some textbooks, they try to give examples about something like a collector that is, oh, this is my the last piece of my collection. So because this is the last one, the margin utility is higher. I read stuff about piano lessons. At first, you don't like it because you suck at piano. You're very bad at it, so it's not enjoyable. And then the more lessons you consume, the better you become, and therefore each successive lesson becomes more and more enjoyable. But both examples, they don't make sense, because when we talk about the law of the diminishing marginal utility, we consider that we consume the same product, okay, exactly the same product. So the case of the collection doesn't really work, because of course the last piece of the collection is not the same as the previous one, simply because it is the last. This is sufficient to make it different, so it doesn't work. And also in the case of the piano lessons, it also doesn't work, because in the process, consumer preferences change. Okay, when if you become better at piano, then your utility function changes. So it doesn't work either. So in fact, I have never found any convincing example of a product for which the margin utility could be increasing. So my advice is, if you want, you can challenge them, and who knows, maybe some of them will come up with a good idea, but otherwise you can just skip that and just tell them, well, this law, well, almost always, if not always, applies. And then you move on. Keep it simple. Right, this you can skip. You see the one step further. The one step further star. Well, yeah, doesn't really matter. Let's skip that. Good for those students who like math. Right, something that is important, because there are some MCQs about that. It's about the shape of the total utility function. And because of the law of diminishing mu, the total utility is concave, okay, as like a bell shape, if you want, which means that it increases usually at a decreasing rate, simply because, of course, each successive unit generates a smaller and smaller increase in total utility, and therefore the slope of your total utility function is going to decrease. And graphically speaking, this means that your total utility function is going to be concave. Yes. And I told you earlier about this diagram, and I told you, hey, look, in this case, you see that total utility increases, but then eventually it starts to decrease. This particular type of consumer preferences We call that non-monotonic preferences. Why non-monotonic? Because the total utility function is not monotonic. It increases and then it decreases. Okay, in math, a monotonic function is one that always increases or always decreases. So a function like that, a total utility function like that, is non-monotonic. What does this mean? It means that the consumer can only increase his or her total satisfaction up to a certain point. Here, 5 units. If the consumer chooses to purchase more, to consume more, then the overall level of satisfaction will start to decrease. Why? Because the marginal utility is decreasing, yes, so the law of diminishing mu applies, but here it becomes negative. But this is a big problem for us, because if this is the case, then we don't know for sure that the consumer will spend all of his or her income. If we have this type of preferences, then it's completely possible that in order to maximize total utility, then the consumer should not spend all of his or her income. And if this is the case, we don't know if the equilibrium will be on the budget line. So that's why we, in this course, at least we consider that, no, that's not going to happen. Instead, we assume that preferences are monotonic here. If preferences are monotonic, then the consumer can always increase satisfaction by increasing consumption. So you will never have a point beyond which your total utility starts to decrease. Yeah, sure, it's going to increase at a decreasing rate. So it's going to become flatter and flatter because of the law of diminishing mu, but it will always increase. Just like the, I don't know, the square root function or the logarithm function in math. These functions increase at a decreasing rate, but they always increase. Why is this convenient? If we make this assumption, if you can always increase your satisfaction by increasing consumption, then you know that the consumer will always spend all income. Okay, always. And because of that, we know that the equilibrium point will be on the budget line. So that's why we assume in this course monotonic preferences. Yes. And what does it mean in terms of marginal utility? This means that mu is always positive. Yes, it is decreasing, but it remains positive, just like the function 1 over x. Yes, 1 over x, it's decreasing, but it's always, for x positive, but it's always positive. And in this case, your total utility function will be always decreasing. Okay, so graphically speaking, that's what monotonic preferences look like. So the total utility increases at the decreasing rate, okay, but it always increases. I can always increase my total utility by consuming more, which indicates here that mu is going to be decreasing. Okay, the law of diminishing mu. Remember that the marginal utility measures the slope of the total utility function, but it always remains positive. Okay, it never crosses the horizontal axis. It never becomes negative. Otherwise, we would have that. All right. If mu became negative, this is what we call non-monotonic preferences. We can only, the consumer can only increase satisfaction up to a certain point. Beyond that point, mu becomes negative, so Tu starts to fall. Something that you should emphasize to your students, and this is not only true for consumer theory, is that the marginal always measures the slope of the total. Could be marginal cost, total cost, marginal benefit, total benefit, marginal anything, marginal utility, total utility, marginal revenue product, total product. For all this, let's say, a relationship between some total something and marginal something, the marginal always measures the slope of the total. Okay, so here the slope becomes negative, so that's why Tu goes down. And here, before this point, mu is positive, so positive slope, so Tu increases. All right, but again, we will not consider this case because it's annoying, because we don't know if the consumer is going to spend all of his or her income. Instead, we'll focus on monotonic preferences. Right, same thing, you can skip this. This is about the too good case. We can skip this. All right, that's beautiful, but it's not useful. Now, let's talk about indifference curves. Let's talk about indifference curve, and that's extremely, extremely important. So let's spend enough time on this. What is it? Actually, I like to start with this. I like to start with this picture, and I ask them, hey, what is it? And they usually understand. So, oh, that's a mountain, and we call that contour lines, which are lines that we draw on a map just to well, have an idea of the altitude. Yeah, because a map is something that only has 2 dimensions. A mountain is something that has 3 dimensions. So of course, when we draw a map, we lose 1 dimension. So in order for us to have an idea of this third, or have a grasp of this third dimension that we've lost, we use contour lines, which are lines along which the altitude is the same. Yeah, if I walk along a contour line, then I will remain at the same altitude. And I also show this map to them, which is another example of something that is very similar to indifference curve. This is actually maps that are used by those forecasting the weather, meteorologists, I think we call them. And along these curves, the atmospheric pressure is the same. Okay, you have here the numbers you see along these curves. We call that isobar curves. And if you could walk along one of these lines, then atmospheric pressure would be the same. And well, then you can tell them we can do exactly the same thing with total utility. We can take the draw a diagram where we would put the quantity of good X on the X-axis, the quantity of good Y on the Y-axis, and we could draw a curve, or several curves actually, but let's start with one. We could draw a curve that shows all the possible combinations of good X and Y that provide the same level of total utility. Okay, so for example, 100 utils. Okay, that gives me one indifference curve. Then I can do the same thing for a given level of total utility of 120 and 140 and so on. I could draw as many indifference curve as I want, and this is really something that you should stress. There is one single budget line, but there is an infinity of indifference curves. Each of them is associated with one particular level of total utility. That's it. Simple, right? They must know the properties of this indifference curve. And well, there are some MCQs, and there was even an essay question a couple of years ago, if I remember well, where that was part A, where students had to explain why indifference curves are decreasing, convex, and cannot intersect one another. That was a bit difficult. So they definitely need to know the properties of this budget line. So yes, first one, the further away you are from the origin, then the higher the level of satisfaction, simply because more is better than less. Okay, and if you move to the, let's say, northeast, this means that you have combinations of good and good X and good Y that have greater amounts in it, so associated with higher levels of satisfaction. Since preferences are monotonic, then indifference curves are decreasing. Why? Because if you buy more of one good, then your total utility will increase. So if you want to keep the same level of total utility as before, then you must decrease the quantity consumed of the other good. Okay, so more of one and less of the other. That means that the slope of the indifference curve is negative. And under the law of diminishing mu, the indifference curves are convex. And I will use a slide in a minute to explain that a bit better. And then finally, transitivity implies that indifference curve can never intersect one another. What do we call transitivity? So perhaps some of you know from mathematics, transitivity is essentially something like if A is greater than B and if B is greater than C, then A is greater than C. All right, so that's what we call transitivity. And I'll show you again with a diagram why, because preferences are transitive, and that's another assumption that we make, why indifference curve, they can never intersect one another. All right, we call these types of indifference curves, I like that very much, we say that they are well-behaved, well-behaved indifference curve. So what do we see? We see that, yes, the further away they are from the origin, the higher the level of total utility. So TU3 is greater than TU2 and TU2 is greater than TU1, okay? Delta TU positive means that if I move in this direction, total utility is going to increase. They are indeed decreasing, all right? And they are convex. I will talk about why they are convex in a minute. So same thing, then what you can do with the students is just to look at these different points, A, B, C, D, and just to ask them, all right, if I give you the choice between C and D, what do you like? What would you choose? And then, of course, they should tell him, I should choose C because it's on a higher indifference curve. Okay, what if you have the choice between B and C? What would you pick? You can ask that to someone else and say, oh, well, in that case, I don't care, right? Because it's on the same indifference curve. So I am indifferent. They both provide the same level of total utility. All right, things like that, just to engage your students and just make sure that they have clearly understood how this works. All right, why are they convex? It's important to understand that, and it's important to be able to explain that. So let's understand why, because of the law of diminishing mu, indifference curve are convex. Okay, so here's one. Just one is going to be enough. And let's start from point A. So at point A, we have a lot of good, oh, sorry, I made a mistake. We have a lot of good y, okay, that's the issues of copy and paste. So here, of course, on the vertical axis, it's good y, not good x. So at point A, we have a lot of good y, but we don't have a lot of good x. What does it mean? It means that, I can actually annotate it, I'm gonna write something. At point A, the marginal utility of x is very high, but the marginal utility of y is very low, okay? Why? Because I don't have a lot of x, so the mux remains high. And on the other hand, I've already had a lot of good y, so because of the law of diminishing mu, then the mu is quite low already, okay? I hope this makes sense to everyone. Okay, so in that case, let's assume that I move from A to B, or at least let's put it differently. Let's assume that I want to consume one more unit of good x. Okay, so delta x equal to +1 means, okay, I consume one extra unit of good x. So essentially I move, okay, let's just do it step by step. I move from there to there. I keep the same quantity of, and let's call that point z. I keep the same quantity of good y, but I consume one more unit of x. What happens to my total utility? Well, it increases a lot, right? Because mux is very high, okay? High, the marginal utility of good x. So one more unit will increase my total utility a lot. So if I want to be on the, if I want to have the same level of utility as I had before, okay, at point A, so if I want to be on the same indifference curve, I need to sacrifice a lot of good y, okay, especially because the marginal utility of good y is very low. So each unit of good y that I sacrifice decreases my total utility only by a little, okay? So you see, one more unit of good x, to keep the same level of utility as before, I need to give up a lot of good y, because good y does not provide a lot of satisfaction at this point. So essentially, that means that from A to B, the indifference curve is very steep, okay? If we continue, now let's do the same thing, but instead of doing it from A to B, let's just look at point C. Point C is the opposite. I have a lot of good x, but I don't have a lot of good y. So what does it mean? Well, that means that here the marginal utility of x is quite low, but the marginal utility of good y is quite high. Okay, again, because of the law of diminishing mu. What happens if I consume one more unit of x? So same thing, I can actually do it step by step. So if I just move from there to there, okay, so I keep the same quantity of y, I just increase my consumption of good x. Is my total utility going to increase a lot? Well, no, because MUX is very low. I've already had a lot of good X, so consuming one more unit is not going to increase my total satisfaction by a great amount. Okay, so I just increase my total utility a little bit. What if I want to keep the same level of utility, total utility that I had at point C? Then, of course, I need to give up good Y, to sacrifice good Y. But then the question is, do I have to sacrifice a lot or do I have to sacrifice just a little? And of course, here, I only need to sacrifice a little for two reasons, actually. First, because the increase in total utility that was generated by an increase in the consumption of good X is small. Okay, my utility has not increased by much when consuming one more unit of good X. And besides, the marginal utility of good Y is very high. So, which means that if I sacrifice one unit of good Y, it's going to cost me a lot in terms of total utility. It's going to reduce or decrease my total utility by a lot, which means that if I want to get back, if I start from point C, okay, I get one more unit of X. And if I want to get back to my initial level of total utility TU1, then I only need to give up a little bit of good Y. And you see, therefore, that moving from C to D, the indifference curve is pretty flat, okay? So you see that, yes, it is essentially convex. What is a convex curve? It's a curve whose slope decreases. That's it, okay, when it's decreasing. And we see that indeed the slope of the indifference curve decreases. And yes, it is due to the law of diminishing marginal utility. Okay, I hope this makes sense. It's important that your students are able to explain it clearly. So to me, this diagram is the best possible explanation for that. Okay, how about transitivity? We said that, yes, because of transitivity, the indifference curve, they can't cut each other. Same thing, can we use a diagram to show that? Yes, of course. Let's just do this, proof by showing that this situation is actually impossible. So these are two indifference curves. Each of them is associated with a different level of total utility. And let's look at three combinations, A, B, and C. So we see that A and B, they are on the same indifference curve, TU2, which means that I should be indifferent between A and B. This symbol here, I think it's called a tilde, means in economics that the consumer is indifferent between A and B. Of course, they are on the same indifference curve, TU2. And same thing for A and C. You see that both those combinations are on the same indifference curve, TU1. So the consumer is indifferent between A and C. However, we clearly see that, by the way, we should conclude if I am indifferent between A and B and between A and C, then by transitivity, I should be indifferent between B and C, okay? But we see that this is not the case here, yeah? We see that C and B, they are on different indifference curves, which means that they do not generate the same level of total utility. And as a result, the consumer cannot be indifferent. And this is why you have the tilde that is crossed. The consumer is not indifferent between B and C. So we see that there is a contradiction. There is a contradiction. Transitivity is essentially not satisfied here when the indifference curves intersect one another. So this is the diagram that I recommend students use to show why, or to explain why indifference curve, they can never intersect each other. Okay, and then you have additional slides on what if preferences are non-monotonic. It's very beautiful, but it's not useful for your students. So you can skip this, all right? You can also skip that, unless you want to challenge your students. You can just, if you are curious, or if you have some time, you can say, all right, what if you have two goods that are perfect complements? For example, you must drink each coffee with 2 sugar cubes. If you do not have your 2 sugar cubes by coffee, if you just have 1, then you can't drink your coffee. And if you have 3, then you will not use the last cube. Well, just ask them, all right, try to find out what's going to be the shape of indifference curve in this case. And you can actually show that this is what they're going to look like. They're going to look like else, yeah. But this is beyond the syllabus. But if you are interested in just trying to check and understand why, just spend some time on this diagram to look at it. And if you still don't understand, or if you are curious about it, just send me a message and I will explain in more detail. All right. However, the students don't need to know this case, but they need to know the case of perfect substitutes, right? The shape of indifference curves when good x and good y, they are perfect substitutes. So two goods are perfect substitutes if to you the two products are exactly the same. Okay, so there are not so many examples. I take the example of Coke and Pepsi, but of course they are not exactly the same. They might, to some people, they might have the same taste, but the simple fact that they have different packages make them different. Okay, but for example, in my case, I really don't care. I am completely indifferent between a blue pen and a black pen, or a blue marker and a black marker. I really don't care. I'm absolutely indifferent between the two. So it depends on consumers, but let's just assume that a consumer is completely indifferent between two products, which means that the consumer regards them as absolutely identical. Then same thing, then say, all right, in that case, what would be the shape of indifference curve? And it's quite easy to understand that in this case, your indifference curve is going to be a straight line. It's going to be a straight line, and the slope is going to be equal to 1 in absolute value. Well, simply because, of course, if you let's say if you start from a situation where you have 4 Pepsis and 0 Coke, if you get one more bottle of Coke, then how much do you have to give up so you get exactly the same utility as before? Well, then exactly 1 bottle of Pepsi, okay? Because to you, they are the same. Same thing if you start from point B, so you have 3 bottles of Pepsi, 1 bottle of Coke. If you get 1 more bottle of Coke, how much do you have to give up so you get the same utility as before? Exactly 1 bottle of Pepsi. So you see that every time you buy one more unit of one good, you should sacrifice 1 unit of the other good to keep the same level of total utility. So that's why your indifference curve would actually here have a constant slope of -1. So it's represented by a straight line. All right. So you can represent several indifference curves in this case. Of course, here TU3 has the highest level of total utility, then TU1, then TU2. However, we will not look at this case because you can see that that's going to be a problem. And usually in that case, we have what we call corner solutions. A corner solution is a solution where the consumer buys only of one good. So it could be only Coke or only Pepsi. We will not be somewhere in the middle, and it's a bit more complicated, so we do not look at this case. But still, your students must remember that if two goods are perfect substitutes, indifference curves are straight lines and they have a slope of 1 or -1. Okay. All right, final word on the first part is a bit long, but because this is where we do the groundwork, and you'll see that part 2 on the price effect is going to be much quicker because we know pretty much everything already. Sometimes students don't really know how to use this verb properly, so you should really, it's really about vocabulary, because we often say you substitute one good for the other, yeah? But what does it mean? If you substitute good X for good Y, do you get more X and less Y, or do you get more Y and less X? Can be tricky, right? So if you substitute good X for good Y, you get more of X and less of Y. So when you substitute good X for good Y, you replace good Y by good X. Okay, that's the idea. Yeah. X replaces Y. That's really how you should understand this verb to substitute, quite important. And I give an example there just to emphasize that, and just to make sure that there is no confusion about how to use this verb properly. Right, the marginal rate of substitution, it is part of the syllabus. It is included, this concept is explained in textbooks. However, again, I don't think you should spend too much time on this because it's not very often tested, right? There are not so many questions about that. But essentially, what your students must remember is that what we call the marginal rate of substitution, the MRS, it's just the rate at which consumers will exchange goods, all right, such that they have the same level of utility. Okay, so for example, oh, if I get 2 more oranges, how many apples should I give up so I keep the same level of satisfaction? And this ratio, this rate, more apples, less oranges, is what we call the marginal rate of substitution. But okay, this is maybe a bit more complicated, but so keep it simple, right? Keep it simple. You don't have to show them this formula. What they must know, however, is that the MRS, this rate at which we exchange goods, measures the slope of indifference curve. Okay, so if you take an indifference curve, you take 1 point, you draw the tangent, and you look at the slope of the tangent, then it is equal to the MRS. Okay, well, that's easy because you can look at the formula dy over dx. That's precisely the definition of a slope. Okay, the change in elevation over the change in the run, that's the definition of a slope, or derivative if you want. But again, just say that the MRS measures the slope of indifference curve. And of course, because we said that indifference curves, they are convex. Okay, this is the same diagram as before. They are convex, the slope decreases, you see, very steep at first and very flat at last. Then that means that the MRS is decreasing. And I can show it, I can actually calculate, this is the example that I used before. I can calculate the MRS from A to B, the MRS from C to D, and we see that the MRS is actually decreasing as we move down along the indifference curve. And then I give an example, but again, it's okay if you skip it, if you don't want to do that with your students, because they will not be expected to calculate a marginal rate of substitution. So it's absolutely fine if you choose not to do this example. But if you want to show your students how to actually do it, to start from one combination and to move to another and to calculate the MRS associated with this change, this example is going to help you. I take 2 examples, apples and pears. You have the calculation here and you have the graphical representation for you to really see how we can calculate a marginal rate of substitution, but do not spend too much time on this. However, you can tell them something that is going to be very important, and especially for everyone here to understand why indifference curve theory is exactly the same as marginal utility theory, is that the MRS is equal to the ratio of marginal utilities. Okay, well, of course you have the proof, but you don't need the proof. But the marginal rate of substitution is just MUX over MUI. If you like math, you can have a look at the proof. It's simple differential calculus. But just, of course, the students just don't need to know the proof, but just remember that the MRS is equal to the ratio of marginal utilities. Why is this going to be helpful? Because this is what is going to allow us to connect indifference curve theory with the equimarginal principle. You'll see that in a minute. Okay, and now we are ready to finally see how the consumer is going to make decision. We've explained everything that is important about the budget line and about what the consumer can purchase. We've said everything we needed about utility, total versus marginal utility, about indifference curves, their properties, about the marginal rate of substitution. So now it is time to bring everything together and to answer the problem. The problem is quite simple. Among all the combinations of good X and good Y that the consumer can afford, because of course we don't consider those who are above the budget line, which one is going to be the best? So what do we mean by the best? We mean the one that provides the highest level of total utility. So this is how you can write the problem more formally, but it doesn't matter. You can just skip this and think about it. And that's why I really emphasized earlier about monotonic preferences. we assumed monotonic preferences. So the consumer can always get more utility by consuming more. So we already know that the consumer, to maximize total utility, will always consume as much as possible. So the consumer will always spend his or her entire income. It is not possible, if we have monotonic preferences, that the consumer will keep some income left. The consumer will always spend every dollar of income. So what does it mean? That means that the best combination of good X and good Y must be on the budget line. And we already have one condition. We know that the best possible combination of good X and Y is on the budget line. And when you think about it, again, in terms of math, what are we looking for? We are looking for a certain quantity of X and a certain quantity of Y, right? That's essentially the problem that we try to solve. We need to find what is the best quantity of X, what is the best quantity of Y. So there are essentially two unknowns, and we have to find the value of these two unknowns. And in mathematics, when there are two unknowns that you try to find, you need two equations. You need two conditions. And guess what? We already have one. We know that, hey, we are going to be on the budget line. That's good, but that's not enough because we only have one condition. That's not enough to find the value of two unknowns. We need a second condition because there are so many possibilities, right? There are so many points on the budget line. So which one is it going to be? We need a second condition, a second rule that is going to help us to understand or to determine among all the combinations that are on the budget line, which one is the best. And guess what? This second condition is what we call the equimarginal principle. And then we will have two conditions. That's going to be enough for us to determine the equilibrium. Let's prove it. So we know that we're going to be on the budget line. So let's start from the budget line. We take any point on the budget line. And let's just ask ourselves, all right, should I change something? Should I move? Should I consume more of X? Should I consume less of good X? And see what happens in terms of my overall satisfaction. So let's see what happens if I gives up 1 unit of X. All right. So I choose to consume less of good X. So of course, this is going to decrease my utility. Because if I have less of good X, then my total utility is going to decrease by an amount that is exactly equal to the extra satisfaction that was provided by this last unit of good X that I consumed. And we call that the marginal utility of good X. So of course, I lose this amount of utility. That's the bad news, of course. But there is a good news. The good news is that because you consume less of good X, well, this means that now you do not spend all of your income. And actually, this means that you now have PX dollars left, okay? Because you consume 1 less unit of good X. And you can use this residual income to buy more of good Y. And with PX dollars, you can buy PX over PY, more units of good Y. All right, I'll give you a second to convince yourself about that. If you have PX dollars, and if the price of good Y is PY, then with PX dollars, you can buy PX over PY, additional units of good Y. And that's the good news, because if you buy more of good Y, your total utility is going to increase. Yeah, by how much? Well, if you consume 1 more unit of good Y, your total utility is going to increase by the marginal utility of good Y, by definition, okay? So if you consume PX over PY additional units of good Y, your total utility is going to increase by MUY times PX over PY, okay? So on the one hand, if you give up good X, you lose utility because you have less of good X, but it gives you the possibility to buy more of good Y and to increase your utility by this amount. So at the end of the day, is it good a good idea or a bad idea to buy less X and more Y? Well, we simply have to compare how much we have lost and how much we have gained, okay? So it's beneficial if what we have gained, what we have there, is more than what we have lost, what we have there, okay? So what we have lost, MUX, what we have gained, MUY times PX over PY. If what we have gained is more than what we have lost, then we should indeed buy more Y and less X. And if I rearrange this inequation a bit, okay, I see that it's the same, that if PX over PY is greater than MUX over MUI, which is the same as the MRS is smaller than the price ratio, then I should consume more of good Y and less of good X. What does it mean graphically? MUX over MUI, this is the marginal rate of substitution. So this is the slope of indifference curves. PX over PY, this is the slope of the budget line. So essentially, this tells you, hey, if the slope of the budget line is greater than the slope of indifference curves, then you should consume more Y and less X. This is how, okay, I'm just skip that. It's the same idea here, same idea. This is how you can graph it. So look at that. If we ask ourselves, hey, is point A the best possible combination? It's on the budget line, so that's a good point. But we see that at point A, the slope of the budget line, PX over PY, is greater than the slope of the indifference curve. Okay, I drew the tangent and I look at the angle here, which see clearly the budget line is steeper. What does it mean? This is what I explained earlier. This means that I should consume more of good Y and less of good X. So I should move up along the budget line, okay? Substituting good Y for good X will raise total utility. And we can see that, right? If I move from A to B, for example, so I still spend all of my income, I'm still on the budget line, but you see that I now lie on a higher indifference curve, an indifference curve that is associated with a higher level of total utility. So whenever the slope of the budget line is greater than the slope of indifference curve, I should buy more of good Y and less of good X. I can do the opposite case. I think it's important to explain it again. So let's just let me do it one second time. So now I can do the same thing, but instead of consuming more Y and less X, let's do the opposite. Let's see what happens if I choose to, if the consumer chooses to give up 1 unit of good Y. So in this case, of course, the bad news is the immediate decrease in total utility by an amount equal to MUY. But the good news is that if we consume less of good Y, we will have some income left. We will have PY dollars left. And we will be able to use this residual income to purchase more of good X. How many additional units of good X? PY over PX. And if we consume more of good X, this is going to increase our total utility by this amount. MUX is essentially by how much my utility will increase if I increase my consumption by 1 unit. So if I want to know by how much my total utility will increase if I increase consumption by PY over PX units, I need to multiply MUX by PY over PX. All right, so same thing. That's the bad news. That's the good news. Overall, was it a good idea to buy more X and less Y? We compare what we've lost, we compare what we've gained, and we essentially conclude that as long as the slope of indifference curves, the MRS, the ratio of margin utilities, is greater than the slope of the budget line. So essentially, if the indifference curve is steeper than the budget line, then you can actually do better. This is what this means. You can do better. You can increase your total utility by consuming more of X and less of good Y. And same thing, that's the same idea here, just explained a bit differently, okay? Graphically speaking, okay, I start from point A and I ask myself, all right, is this the best possible combination? Okay, so we are on this level of utility. But what do we see? We see that at point A, the slope of the indifference curve is greater than the slope of the budget line, okay, which means that I can do better. I can increase my total utility by consuming more of good X and less of good Y. So I should move down along the budget line, let's say from A to B, and you see that I can now achieve a higher level of total utility, a higher level of satisfaction. Okay, good. So overall, what have we learned? We have learned that, look, whenever the MRS, or the ratio of marginal utility, is greater than the slope of the budget line, I can do better. I should buy more X and less Y. If, on the other hand, the budget line is steeper than the indifference curve, it's the opposite. I should actually buy more Y and less X. So the only situation where we should not move, the only situation in which we have actually found the best possible combination of good X and good Y, is if the slope of the budget line, Px over Py, is exactly equal to the MRS, the ratio of marginal utilities, the slope of indifference curves. And guess what? This is what we call the equi-marginal principle. Let's just show it more explicitly. I think we are clear with that yes, the best combination is when MRS equal to Px over Py, but we know that the MRS is the ratio of marginal utilities. Okay, I've proved it earlier. So if we rearrange this equation a bit, boom, we end up with the equi-marginal principle. And that's why I really don't understand why Cambridge seems to distinguish between indifference curves and marginal utility theory, because you see that it's just the same thing, right? It's exactly the same idea. And this is our second condition. I told you to find two unknowns, we need to have two conditions. We already had one. We must be on the budget line. Here's the second one. We need to make sure that the marginal utility per dollar spent on each good, on good X and good Y, they must be equal. And that's it. We have our two conditions. And with these two conditions, I'm going to skip that. And with our two conditions, I'll move to the diagram first, and I will get back to this. With our two conditions, we can show the equilibrium of the consumer. I know that I must be on the budget line, and I know that the best combination is such that the slope of the budget line must be equal to the slope of the indifference curve, which is the case at point E. So this level of total utility is the maximum level of total utility that the consumer can achieve. What I like to do is to show this diagram to the students and tell them, all right, what can we say about, let's say, point A? So point A, it's good because the consumer spends all income, but it's not good because we clearly see that the slope of the budget line is not the same as the slope of the indifference curve. So that's not the best point. Point B, here in that case, the slope of the budget line is the same as the slope of the indifference curve, but it's below the budget line, so the consumer can do better. The consumer has not spent all income. Point C, point D, they are unattainable, so we can just ignore them. The consumer cannot afford them. So yes, the best combination is indeed point E. There is this tangency between the highest possible indifference curve and the budget line. And we are on the budget line, and the slope of that budget line is the same as the slope of the indifference curve. So this is what we call the consumer equilibrium. Just to see what happens, let me go back a bit. What happens if the equi-marginal principle is not satisfied? And that's what I explained, and that's essentially exactly the same idea as before, but just explained slightly differently. If the marginal utility per dollar spent on good X is greater than that spent on good Y, then that means that we should buy more X. That essentially means that good X can purchase more utility, that each dollar spent on good X is worth more utils than each dollar spent on good Y. So of course, in that case, we should reallocate or modify our consumption by more X and less Y. And this is gonna restore the equality between the marginal utility per dollar spent on each good because of the law of diminishing marginal utility. If you buy more of good X, then MUX will decrease. And if you buy less of good Y, then MUY will increase. And therefore, the right-hand side of the inequation will go up, the left-hand side will go down, and this will restore the equality. Same thing if each dollar spent on good X is worth less in terms of utility than each dollar spent on good Y, so this is this case over here, then the consumer should actually spend more money, more of his income on good Y and less on good X. More on good Y means we buy more of good Y, and therefore MUY is going to go down. So the right-hand side of the equation goes down. Spending less on good X means because of the law of diminishing MU that MUX is going to go up, and therefore the left-hand side of the inequation is going to rise, and eventually the inequality is going to be restored. Simple. Then you have this exercise. You can do it with the students. That's quite easy. So I give you a certain income, the price of good X, the price of good Y, and these are the quantity of each good. So I give you the marginal utility. Okay, it doesn't matter, just give it. The students can then calculate, they just have to divide by the price, and they can calculate the marginal utility per dollar. And then what you can do is just to ask them, all right, let's say we start from 0. We don't have any of good X and we don't have any of good Y. Should we first purchase 1 unit of X or 1 unit of Y? We see that the MU per dollar spent on Y is greater than the MU spent on X, right? Well, 100 versus 40, which means that good Y, each dollar spent on good Y is worth more utility than each dollar spent on good X. So we should buy 1 unit of good Y first. All right. And so, of course, my the income that I have left is only $25 now. And then I do the same thing. Should I buy a second unit of good Y, 70, or first unit of good X? So same thing. I compare the worth of a dollar spent of each good in terms of utility, and again, good Y is more attractive. So same thing, it's better to buy a second unit of Y. Then a third question, should I buy a third unit of good Y or a first unit of good X? Again, 60 greater than 40. And then, well, you see in what comes next is that it's the same. So we could tell that, all right, in that case, the consumer is going to buy 1 of each, okay, 40, 40. Then should I buy a 5th unit of good Y or a second unit of good X? Well, again, now it's good X, which is more valuable in terms of utility. So I should buy a second unit of X, blah, 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 blah. We continue until there is no more income, all right? And this combination does, well, of course, I picked numbers in a convenient manner, but this combination, 5 units of X and 6 units of Y, does satisfy the equimarginal principle. You see that eventually the consumer, or the combination of good X and good Y is such that each dollar spent on good X is worth the same as each dollar spent on good Y in terms of how much utility they can generate. Right, this diagram is not required. I like it, but it's not required, so it's fine to skip it. And essentially, to summarize, this is how we can describe consumer equilibrium. First condition, we will be on the budget line. Okay, that's your first equation. The consumer is going to spend all income. Second condition, the equimarginal principle. The MRS is equal to the price ratio. The slope of indifference curve is equal to the slope of the budget line. The marginal utility per dollar spent on good X is equal to the marginal utility per dollar spent on good Y. You have the diagrams to summarize, and to conclude, there is a small, simple exercise that I stole from an AP textbook that explains, or that just tests the students' knowledge. They just have to check the equimarginal principle. So they have information about the MU of each good, the price of each good, and they just have to check whether the equimarginal principle is satisfied. And if not, and actually it's not, to conclude, what should we do? Should Echo purchase more of X and less of Y, or the opposite? So of course you have the key. And that's it. Yeah, that was a bit long, but we are here. We are really like setting up the foundations for the entire consumer theory. And if your students understand that pretty well, then it's going to be like the rest, like the price effect and all, is going to be quite easy. So the teacher slide has a lot of slides, 207. The student slide is much shorter. It's still long, but shorter, only has 58. And of course, you don't have the answer here for this exercise, for example. Right, and the summary is even shorter. The summary is only 5 pages. Look at that, only 5 pages, and it really summarizes everything that the student, with all the diagram, all the possible cases, indifference curve, the equimarginal principle, consumer equilibrium, blah, 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 everything, like the key points are there. Key definitions as well. You can find them on the online dictionary. You also have, yes, the concept cards and so on. Okay, any questions before we talk about the price effect? Please let me know. We're going to talk about that, the decomposition of a price effect. Please type your questions. We're going to take a few minutes to relax because I need a few minutes to relax too. That was a bit intense. All right, so please let me know if you have questions.